بسم الله الرحمن الرحيم رب زدني علما.
So now the next thing we'll try to understand the packet format, which basically involves in encapsulation of your VXLAN packet. So let's try to see that. Now, the first thing, now let's try to break down the VXLAN packet format a little bit step by step. The first one will start from here, the original Ethernet frame. Now, in the previous sections already we have covered about the entire how the VXLAN process actually happens and the differences between the VXLAN and the VLAN and the data plane overview, all these points. So the first one is the original Ethernet frame. Because the process actually starts from your original Ethernet frame. This basically contains the payload inside, because the payload is nothing but the data, the actual data which is supposed to be transmitted, along with layer 2 addresses, layer 2 your MAC addresses, the source and the destination MAC addresses, and then also it has some Ethernet type, which type of Ethernet field. These are all information similar to your normal layer 2 packet. So that is your actual original Ethernet frame, which contains this information. Now, what happens is this particular original Ethernet frame is further encapsulated into the VXLAN header. Now, again, this VXLAN header is going to play a crucial role inside the VXLAN overlay. And this VXLAN header contains multiple things. Like one of the main important thing, we have something called VNI, virtual network identifier, that is basically identifying which VXLAN segment it belongs to. Just like the VLAN ID, we have the VNI ID or the VXLAN network identifier. And based on this identifier, basically the devices within the same VXLAN segment will be able to communicate once they identify this VNI ID. And then there are some reserved bits. You can see there are some reserved bits as well. And these reserved bits are typically reserved for the future purpose or the future use. And also there will be some flags. Basically these flags will indicate specific features or the functions, those information. Also, there will be some group policy bit will be available, depends. And that will identify the group policy specifically for multicast or the broadcast traffic. That can also be available inside this VXLAN header. Now, this VXLAN header fields is going to provide the necessary information to route the packet within the VXLAN network. So the VXLAN network, the packets are forwarded based on the VNI ID, and all the information relating to the VXLAN overlay network will be present inside this VXLAN header. Now, the next thing is now further, this particular VXLAN encapsulated packet is further encapsulated into the inside the or within the UDP header, we can say. Now, what is UDP header? Now, this UDP header is going to provide you the information about the transport layer information, mainly the transport layer information of the VXLAN packet, ensuring that the packet is routed across the IP networks. So basically, it contains the source and the destination port numbers. So this basically contains the source and destination port numbers, which will be used for the transport or at the transport layer. Now, again, if you go further, this particular UDP header or the entire UDP encapsulated VXLAN packet is then again encapsulated into the outer IP header. Now, this outer IP header, as you can see here, this outer IP header contains mainly the source and destination IP addresses. Now, this is basically the source and destination IP addresses of the loopback of the devices, actual devices. Like if you take an example, I'm trying to send the information from switch 1 to switch 3, and in between you have some other devices. And probably this outer header will include the information or the router ID of the loopback addresses of the originating and the destination devices. And again, these IP addresses represent the next hop or the target device IP addresses. So these outer source IP addresses and the destination IP addresses are typically, we can call it as a VTP, virtual endpoint devices, or where exactly the encapsulation and decapsulation happens, and typically referring to the source and destination devices, source and destination devices or source and destination VMs if you're using in a virtualized environment. And finally, after that, you will have, there is something called outer MAC header. Now, this entire packet is again including the outer IP header. This outer IP header is sent in a new Ethernet frame. So basically, this new Ethernet frame is having its own set of source and destination MAC addresses. Now, this is again typically the MAC addresses of these devices. So the switch 1 and switch 3, because again, as I said, the packets are being routed based on this outer IP header. So this will be again further, we'll be adding the source and destination MAC addresses. So typically the source MAC address is the outgoing interface of the device. Let's say this is the device, and the destination MAC address will be representing the next hop. So typically, what is the next hop? Not the destination. We can say it refers to the next hop device. It has to route the packet in order to reach the final destination. So this is what it includes. So the final transmission, if you take the resulting encapsulated packet within this original Ethernet frame, is nested like this. So the original Ethernet frame is nested within the VXLAN, and then the VXLAN into the outer IP header, and then to the IP headers, and then it is being transmitted over the network. Okay, so again, once it reaches the destination will again do the reverse process. Reverse process is kind of a decapsulating the packet. So first it will see the MAC, and then it will route, and then based on the outer IP header, and finally it is going to reveal the original Ethernet frame, and that original Ethernet frame will be forwarded to the targeted device in that. So in this, as you can see, there are multiple things happens inside the VXLAN encapsulation. So I thought you need to understand this process. So basically, the VXLAN complete packet format includes the encapsulation of your original Ethernet frame within the VXLAN header, and then it is being followed by the UDP header, and then the outer IP header, and then finally the outer MAC header. So this layered encapsulation allows the complete VXLAN technology to use the virtual network overlays, means whatever the virtual network which is being built, or the virtual overlay network which is built, it requires this process. And basically this process is going to extend your complete the VXLAN network, that is a typical layer 2 network, over the layer 3 infrastructure, which enables the communication process which is required in the modern data center and the cloud environments.